So today we're going to be talking about basic volume and then expand it into something a little bit more calculus related. So here we have first the area of a circle. We know that the area of a circle is pi r squared, right? And basically the area tells you how many squares are on the circle. In this case, it happens to be, let's just make a guess. I'm going to say that there's 30 squares. Now, what is volume? Well, volume is basically adding a layer. So what I did is I grabbed this area, put it on top, and then I added depth, or also known as height. So I went ahead and added one layer. So each one of these little things that you see is actually a cube, okay? So each one of these that you see is a cube. So if I had 30 squares and then I went ahead and added a layer, how many cubes do I have? So how many cubes do I have? So I added only one layer. So think about it. Interesting. So in reality, this is going to be 30, guys. So I've noticed a lot of answers. So this is going to be 30 because all I did, basically I had a square, right? And what I did is I added depth. So I have this square now be a cube. So if I had 30 squares, now that I added one layer, then this is going to be 30 cubes. Now here on the next example, where we see volume given 3 layers, that is basically telling you, let me see something. I think I had someone in the waiting room. No. So here we have 3 layers. So in other words, what's happening is I'm adding 2 more layers here. Oh, sorry, my drawings might not look so good. So now I have 3 layers. So if originally I have 30 on top, 30 here, and 30 here, how many cubes do I have in total? How many cubes do I have in total? Come on. I need everybody to think about this. So I had 30 cubes here. Now I have 2 more layers. Then it should be that I now have 90 cubes. Okay. And basically what I'm trying to tell you is that if you're given the area, all you have to do is multiply by the height or the depth, and that's going to give you the amount of cubes that you have. Okay. That's the only thing that I'm trying to say here. So all you have to do is, given the area, so the area is pi r squared, you multiply by the height and you get your volume. So volume is equal to pi r squared times h. Okay. Or another way that you can think about it is volume is equal to the area times the height. Okay. The area times the height. So now I'm going to go ahead and now introduce calc. So this is the part where you have to be the most attentive. So I'm going to go ahead and copy this. I'm going to paste it over here. Okay, and let's see. I'm going to go ahead and let's rotate it actually. So I'm going to rotate it like this. Let me move it somewhere over here. All right, so I went ahead and put it on my x-axis, okay? So does that change my volume at all? So remember, volume is the amount of cubes needed to fill the cylinder. So does that change my volume? No, right? So the volume is still going to be the area times the height, okay? So it is still the area times the height. Now notice that I don't have to go ahead and do the whole thing. I could have also done it this way, right? I could have gone ahead and done this. So I could divide it into layers and then find the area of each layer and then just add them up, okay? So I could cut it, find how many cubes are in each layer, and then add them up. That's another way to do it. So it's pretty simple to figure it out once you have something that is solid. But what happens when you have an irregular shape? Okay, so now we're interested in something a little bit more complicated. So let's go ahead and paste my previous cylinder, if it lets me. Okay, so here, let's rotate it to the right. Let's go ahead and move it. somewhere around there. Okay, close enough. And basically what I'm going to do now is change it, right? So I'm trying to find irregular shapes. As you guys remember, calc is basically the study of finding irregular shapes. And actually, before I do that, let's go ahead and make it also. Let's see, can I do that? So I want to go ahead and shrink it. So I'm going to go ahead and shrink it a bit and then move it. Okay, so I'm trying to shrink it, make it a little bit bigger, make it a little bit nicer so that my diagram looks nice. Now I'm going to erase it. I'm changing some dimensions. Imagine now that it's something like this. Okay, so I'm trying to find the volume of a basic cylinder, but this volume is going to be of an irregular shape. Okay, so although it looks like it's constant right here, in reality it's slowly and slowly increasing till you get here. Okay, now how are we going to approach this problem? We're going to approach it the way that we said it before. So remember, I can go ahead and cut this one into different layers, right? So I can cut into different layers and then add them up, and it should be equal to the total. So the sum of the parts is equal to the total. So here I'm going to do something similar. I'm going to go ahead and do this. So I'm going to go ahead and make smaller and smaller cylinders. Okay, smaller and smaller cylinders. So something like this. And then what I'm going to do at the end, find the cylinder, find the volume of each cylinder, and then I'm going to go ahead and find my my volume. Now here comes the hard part. So if you guys remember, this is similar to finding the area of a curve. Now you may be asking, well, how is that similar? Well, basically what I did is I rotated around the x-axis. So I had something like this. So where you have kind of like rectangles here, and all I did was rotate it around. Okay, I rotated it around. And then I have these many cylinders. Okay, I mean, so yeah, smaller cylinders, right? So each one of these rectangles is basically going to be a cylinder once you go ahead and rotate it. So each one, like I said, of these rectangles is going to be a cylinder. So let's give a quick example. Oh, and actually I used pink. So let me use pink. When you go ahead and rotate it, it's going to look something like this. Let's see, that one came out a bit off. Okay, so this is the cylinder. And basically this is the rectangle. So I grabbed the rectangle and I rotated it around. Okay, so I rotated it around, and you can see that what's going to happen here is going to be a smaller one. Now this is not the same one as that one that I have here, but it's a representation, basically the same concept. So let's try to figure this out. So if I went ahead and cut each one of these into the same basically same height. So each one of these cylinders, remember I turned it around. So this is going to be the height and this is the base. So each one of the heights is the same. So let's find basically the volume for this one. So the volume for this one is going to be pi r squared of the first radius. Okay, so the radius of the first rectangle or first cylinder, and then times the height. Okay, now the height for this one, well, let's say how many did I have? 1, 2, 3, 4, 5, 6, 7. Okay, so I have seven of these cylinders. So the way that you usually find it is you do b minus a divided by what? Does anybody remember? How do I find the length of each one of these? I do b minus 7 and I divide it by what? So think about it. Come on, guys. So I do b minus 7. I mean, b minus a. So this is my b, this is my a. And then I have to divide it by the amount of rectangles that I want, right? So if I only wanted 2 rectangles, then I divide it by 2. I divide the length by 2. But if I'm going to have 1, 2, 3, 4, 5, 6, 7, then I have to divide this by 7. All right. So this is going to be by 7, or in this case, I'm just going to use a general B minus A over N. And then the last one is going to be volume is equal to pi r squared. And then this one, they usually call it I, okay? They call it I because it's the last one, is the last cylinder that you have. I know that this is 7, right? We know that this is 7. However, it could be many more, or it could be less. It doesn't matter. But essentially, you're still going to have B minus A over N. Okay, now comes the part to connect this all and to get something that we're going to love, because it's going to make our life super, super much easier. So this B minus A over N, does anybody remember what is another name for that? We have another name for it. There's an easier thing that we can use instead of B minus A over N. Oh, I like it. So far I see one person have it. Yes, this is connected to the Riemann sum. So what is this part? This part has a special name. Aha, the symbol is a triangle. So anybody remember what the triangle is? What is the name for the triangle? Try to guess. What is the name of the triangle? Triangle X. What is triangle X? There's a name for it. Yeah, I like some of the answers that I'm seeing. Okay, and someone asked, what about the middle? I apologize. How about the middle? So for the middle, you have something like V is equal to pi. This is the third one, so this will be R3 squared. Oh, I thought I hanged up. Okay. So again, pi R3 squared. And basically, you guys are correct. This is the change in X. So the pink stuff here is actually known as change of X, okay? So now, why do we call it change of X? Because if I want to go ahead and get the exact solution, how many, so if I want to get the exact volume, how many rectangles or cylinders should I use? If I want to get the exact volume, how many cylinders should I use? How many of these? If I want to get the exact solution, because you see right now I have little gaps. So I want to get the exact solution. So I want to take N2. I want to make N infinitely large, okay? Not just a million of these cylinders. I want so many more. I want a billion. I want an infinite amount. Infinity is such a huge amount that we don't have a number for it. Okay, so I'm going to take N to infinity. So then now here comes the part that you don't have to remember, but it is important for you to realize what it is. You take the limit as basically we can say something like I is equal to 1. So it starts at 1 and we're taking it to infinity, okay? So we're taking N to infinity, or actually I think it's the other way around, right? Or let me just write it in normal notation. So the limit as N approaches infinity of the Riemann sum, pi r I, so the depending on the radius of the cylinder that you're working on squared, so the area times the change in X, okay? So times the change in X is gonna give you basically the volume. Now, the reason why I said you don't have to remember this one is because we have a better choice for this. What is the limit as N approaches infinity, sigma? What do we use instead of that? What do we use instead of sigma and the limit N approaches infinity? We use something far better. How is Riemann sum connected to area? Remember? When we find the area, we don't use Riemann sums. We use something easier. So we don't use the Riemann sum. We use something easier. What do we use? We don't want to use the limits. Remember, limits are significantly harder. We want to use integrals, okay? So we want to go ahead and use integrals. So there's going to be integral of the area, okay? The area in terms of x, dx. So the area in terms of x, dx. That's how you go ahead and find the volume of a solid. You find the volume of a solid by basically finding the area of a random cylinder, and then you multiply by its height. The height is going to be dx, okay? The height is going to be dx. So let me go ahead and show you something. Oh, I actually don't have it here on this one. Okay, so let's check another one. Let's see, can I use calc? It's not this one. I'm not sure if I can access it from here. I'll try. I guess I can. Okay, so this is going to be an explanation. So right now we're working with something close to, let's see, 0, right? And my fingers are hard to control. So you get the idea. And then V, we could be anything. And then we could use any number of n. So you notice that I can use 6, 7, 9, whatever. And let me go ahead and change the filling. So we are filling them. And then basically what we're doing is we're spinning them, okay? So we're moving them around. And let's use a smaller amount so you can see clearly what's going on. So from the top, this is how it looks, okay? And then here on the side, you can see how it's, when I rotate it, it goes ahead and gives me the filling. So I can go ahead and rotate it all. And this is what we use to make things like mugs. We make things like, what do you call it? Planes. We make a lot of things. I mean, you can make simpler things like, for example, what do you call it? Glasses, champagne glasses, pipes, a lot of things. And it's not super, super hard, but it does take some knowledge of basic integrals. So this is our goal. Our goal is to have this, but we want to take our n to infinity. So we want to get so many more. Notice that as my n increases, this becomes a lot and a lot better approximation. Okay, so that's basically what we're going to be doing. Any questions so far before I go into some examples? Okay, so I don't have any questions. Okay, so let's go more in depth. So this part, like I said before, those of you who are taking the AP Calc exam, you already saw this part. The only part that was new was the previous part. However, you can go ahead if you wish, get started on the questions that you see on your Schoology. But for the rest of you guys, please follow along. You guys have not seen this yet. All right, so rotation about the x-axis. Basically, what I showed you here on top is an example for rotation around the x-axis. Okay, so we're rotating around the x, but it's also possible that you can rotate it about the y, okay? And now, how do you know if you rotate it around the x or around the y? Well, simple. They're gonna go ahead and tell you what you need to use. I noticed that I only drew a one disc. These are known as discs. So I only drew one disc because we only need a sample, okay? We only need one to figure out the rest. And basically what you have to do is find your R, okay? And then for when you're given rotation around the Y, you do the same thing. Well, then how do you know your R? You may be asking yourself, well, this is the way that you figure it out. Essentially, substituting or plugging in, you are plugging in an X value to get the length of your R. So I'm plugging, for this one, I'm plugging in an X value to get my R, right? R, which is the Y value corresponding to that X value. So when I make my sample cylinder, I notice that I'm going to be plugging in this value in the center to find my R. So that's how I know that my equation has to be in terms of X. Now, how about for rotation about the Y? Well, I'm using a point on the Y axis, okay? So that means that my equation has to be in terms of Y, and my discs are also being stacked, or the height of each one of my cylinders has to be in terms of Y, okay? The easiest way to remember this is the following. If the discs are being stacked parallel to the x-axis, then you're going to use X. If your discs are being stacked parallel or on the y-axis, then you're going to use the y. So dx if you're parallel to the x, dy if you're parallel to y. Any questions? All right, so I'm glad. I'm trying to simplify this. I know this seems a little bit overwhelming, but you'll notice that the book actually goes ahead and does it a little bit differently, slightly, but I went over the key topics. If you wish, you can also look at the book. And I also went ahead and worked the examples so that you have these on your notes. I will not go over these examples. However, they will be available to you if you wish to look at them. I'm going to go straight into your assignment, okay? Now, before we go into the assignment, I do want to show you this. Okay, let's see some questions on the chat. This lesson gave me a whiplash compared to Wednesday's lesson. True. Yeah. So Wednesday's lessons. Yeah, but I mean, we'll see some examples right now. And I also want to make sure that I differentiate some things. Like I said, this lesson is lesson 6-2, but we're gonna go ahead and distribute it into 3 different parts. Maybe it's gonna take us about 2 to 3 weeks to cover just this one lesson. Okay, identify, so summary, identify whether your R is in terms of X or Y, okay? This will let you know whether to use dx or dy. Dx and dy tells the function how to stack the disks, okay? And then this second part, you don't have to worry about it. We're gonna see this next, so this is gonna be our next episode. This is gonna be washers. So you don't have to worry about that. You're gonna see it on your notes, but don't go ahead and do this. And the reason why we use washers is one, that this, if you guys haven't seen this before, a washer is what you use when you have a bolt. So it basically stops the bolt from going ahead and hardening to, for example, wood or plastic, depending on what you're using. But a washer could also be used for different purposes as well. Okay, so you don't have to worry about that for now. Let's go ahead and look at that's period 6. We did this. And then I did show you rotation about the y-axis. I don't have it on this one, so I'll quickly show you. So basically, you're going to be given the function from a certain interval, and all you have to do if it's rotation about the y, so then just reflect. So 1, 2, 3, 4. I'm going to reflect it here, and then just make a sample cylinder. So I'm going to make it like this, try to give it some curvature, and then like that, and that's your sample cylinder. And I like doing these little lines just so that I know that this is my height or my dy. So, okay, everybody please go and open on Schoology A2. So go to Schoology, please, and open A2. So if you go to Schoology and then you go to your calc, you're gonna go to 6-2 and then view attachments, and it's gonna be there. So here you're gonna be able to see the different questions that we're gonna be doing. These are not gonna be on Delta Math. You will be submitting this. if we have Kami, do we open it with that? No. I mean, you can if you want to, if you want to put the answers there, but I do want to see the work in a separate sheet of paper. This is not enough space to do this kind of work. There is no way that you can do all the work that is required for this on that amount of space. So please do it on a separate sheet of paper. If you wish, one thing that you can do is put the graphs here, but I recommend just doing it on a separate sheet of paper. That will make it easier for you. Okay, any questions on where to find the work? Okay. Yeah, so those of you who are taking the AP Calc, you do have to do this one. You do this, you will have to do this assignment. So like I said, you don't have to stay with us. However, if you wish to stay with us, you may. So for each problem, find the volume of the solid. So we have this things that we're given. So these are going to be boundaries. So we have y is equal to negative x squared plus 1. First thing you have to do is quickly sketch it, okay? So you have to quickly sketch what you are given. So I already have my x and y. So if you don't have this, please go ahead and make a quick x and y. And then I'm gonna use 2 squares for this one. So this is 1 and this is negative 1. And then it says y equal to 0. Well, first of all, let's go ahead and sketch this. It looks kind of ugly. I apologize. And then this one looks like this. Okay. Okay. Here's the part where some of you may get confused. Y equal to 0. Y equal to 0. Think about it. Is that going to be my x or y axis? Y equal to 0. How would you graph y equal to 0? Is that going to be my x or y axis? Y equal to 0. So y equal to 0, think about y equal to 1. Y equal to 1 is here, and the line is going to be basically like this. Okay, y equal to 1 is horizontal. So y equal to 0 also is going to be horizontal. So it's going to be my x-axis. So in other words, I don't care about what's happening below my x-axis. So I'm going to go ahead and erase it. And, or you don't have to erase it, but I want to go ahead and make sure that I don't confuse you. So this is also y equal to 0. Okay, now here comes the axis of rotation. They're telling us that the axis of rotation is y equal to 0. So that means that I'm going to rotate it around the x-axis. So go ahead and make this symbol. This symbol is like this. That's called a rotation symbol. So go ahead and put it there. Basically, this is what we're going to be doing. And now on your second graph, so you're going to be using 2 graphs. On your second graph, you're going to go ahead and sketch your rotation. So this is like this. And then here, this is going to be my reflection. Okay, so that's my reflection across the x-axis, or also known as y equal to 0. And because I'm doing a rotation, then I'm going to have my cylinder like this. Okay, so that's a sample of my cylinder. Again, that's a sample of my cylinder. Now, the reason why you want to have a 2D and a 3D dimension a graph is because sometimes one of them is going to be easier than the other. So I'm trying to find the radius, okay? So I'm trying to find the radius. I picked this point, okay? So is my radius gonna be, the length of my radius, is it gonna be the Y value or the X value? Think about it. Okay, is the radius gonna be my X value or my Y value? Come on, guys. This is not a simple lesson. Please, please, please try to follow along. Okay. The radius is going to be my Y value, right? Because the X value is here. So the X value doesn't give me anything. The Y value gives me the length. Okay. It gives me the distance from here to here. Okay. That's the first thing. Second thing, are the discs being stacked on the X axis or are they being stacked on the Y axis? Are the discs being stacked on the X axis or Y axis? Stacked on the x-axis. So remember, if they're being stacked on the x-axis, then we're going to be using ax dx. Okay, so ax dx. Okay, and that means that my limits a and b have to be in terms of x. Okay, so where does it begin to be stacked and where does it end being stacked? So where does it begin? Where does it end? On what values of x? On what values of x does it begin being stacked and does it end being stacked? Yeah, from -1 to 1, right? And if you didn't know why this is -1 to 1, is because of the graph of this function. So now let's go ahead and plug in our different answers. So this is going to be from -1 to 1. The area, we're using a cylinder. So this is going to be pi r squared and then dx. And then now we can go ahead and make this easier on ourselves. From -1 to 1, I'm going to move the pi to the front. And now I have to think about my r. So what did we say about the r? The r is going to be the y value. In other words, it's going to be the function, okay? So the function, y is equal to this, okay? So the function is what's going to be my r. So my function is going to go here. So the function is -x squared plus 1. And then squared, and then dx. Okay. Is there anyone so far that is confused on what we're doing? And that's it. You're done. You now just have to give the answer. You just have to use simple integration techniques. So first, let's go ahead and simplify this. So -1 to 1. This is going to be, let's see, x to the power of 4 minus 2x squared and then plus 1 dx. All right. Okay, now I can take my antiderivative. This is going to be pi x to the 5th over 5 minus 2 x to the 3rd over 3 plus x. My limits are from -1 to 1. This is going to be pi, and this is the part that I'm going to use double brackets because you have the outside and then you have the limits of 1. So it's going to be 1/5 power over 5 minus 2, 1 to the 3rd power over 3. plus 1. And then here you have this minus from the general rules of integration. And then this is going to be minus 1 over 5 minus 2 minus 1 cubed over 3 minus 1. And then finally close this. Any questions so far? Okay. I'm going to go ahead and then simplify this. This is going to be, let's see. This is going to be 1 over 5 minus 2 over 3 plus 1. And then here, this is going to be minus 1 over 5 plus 2 over 3 minus 1. Yep. There's going to be pi. And basically, all of this is going to simplify 15, right? So this is going to be six over 15 minus 10 over 15 plus 15 over 15. And then minus, let's see, times 3. So there's going to be 3 over 15 minus 10 over 15 plus 15 over 15. So all you have to do is add all the top numbers. Why is 1 over 5 positive? Let's see, 1 over 5. Thank you for that. So this one should be positive, right? Because this is negative right here. So let's see, what is that going to give me? So let's do, on the top, this is going to give me negative 4. This is going to give me 18. These two are going to give me 5. So let's see. Sorry, I have something to check real fast. Okay, so we have, okay, changed it. There's something off. I see that something is off. What is off? Oh, true. The 6 over 15, right? Yeah. Because that should be 3, right? Thank you for that. Because remember, we multiply this one by 3. Dun, dun. And then this is going to be now negative 7. So negative 7, so it's going to be negative 2. So our answer is 16. 16 over 15 pi. So the answer should be 16 over 15 pi. Here, you had to multiply by 3 on the top and the bottom. And that's pretty much it. Here, I noticed this later, but it actually is easier if I would have added the fractions here, okay? So on this step, if I would have distributed and then added the fractions, because you already have common denominators. So here, if you notice, it would have been a lot easier if I would have combined this one and this one, and then this one with this one, and then these two, okay? After I have distributed the negative. If I would have done that, that would have been saved a lot of time. But we can do that for the next one. Any questions on this one so far? And then also, I did go ahead and give you the answers to these questions on the bottom of your page. So you do have that to your, you have that as a resource. However, I do want to see the work. If you don't show me the work, then you're not going to receive credit. So let's try the next one. Okay, let's start by graphing this. Now, the first thing that you'll notice about number 3, and some people didn't finish that one, so I'll have it there. The first thing that we can notice about number 3 is that we have x is equal to y cubed, okay? So x is equal to y cubed. First of all, if I'm graphing it on the x and y, this is gonna be pretty hard to graph. So what I'm going to do is I'm going to solve for y. So if I solve for y, this is gonna be the cube root of x is equal to y. And that is actually something that we know how to graph, right? So again, I'm using the x and y coordinate plane. So I want to go ahead and have this in terms of x. And now to graph it, well, what is the cube root of x? I know that my original cube is something like that. So the root has to be something like this, okay? But however, I need it to be bounded, okay? So I'm giving more pieces of information. X is equal to 0. So x equal to 0, is that gonna be the x-axis or the y-axis? Is that gonna be the x-axis or y-axis? It's gonna be the y-axis, right? So it's gonna be this one. So if I'm using this one, then what I'm trying to do is go ahead and cut it here, okay? So in other words, I'm only gonna be interested in one of the two sides. So now I have to use my second key information that I have here. So y is equal to 1. So y is equal to 1, okay? So y equal to 1, let's go ahead and put it over here. So this will be my 1. And then, so I'm bounding it by this, the y-axis, and my y equal to 1, which is here. So you have this. So all I'm interested is in this part. I don't really care about the bottom part. So what I'm going to go ahead is I'm going to go ahead and regraph this, but only focusing on the parts that I am given. So the y-axis, y equal to 1, and the graph itself of the function that we started with. All right, so this is now a sketch, a 2D sketch of what we're working with. And now what I want to do is I want to go ahead and make my disk. So if I'm trying to make a disk, I have to decide, well, how am I going to rotate this? And now this is the part where I would like for you to answer. Go ahead and tell me in the chat, where do I rotate it? On the x-axis or the y-axis? So think about it. Where do I rotate it? Where is x equal to 0? The y-axis or the x-axis? So thank you for those of you who went ahead and answered. You are correct. This will be the y-axis, okay? So x equal to 0 is going to be the y-axis. Remember, x equal to something, x equal to a number will always be a vertical line. So in this case, it happens to be the y-axis. So I'm rotating it about the y-axis. So like this, meaning that I'm going to have, so let's go ahead and quickly make a sketch. So something like this. And remember, I want to go ahead and have a visual representation of my disk. So let's go ahead and make it somewhere random. It doesn't have to be in the middle, but I do like this. So I'm going to add some depth. And this would be my disk that I'm working with. Okay, so this is the disk that I'm trying to stack along the y-axis. Okay, so if I'm trying to stack this along the y-axis, think about it. Which of the two functions should I use? So if you recall, we have two different functions. We have dx, and then we also have our a of y dy. So which of the two should I use? The one with dx or the one with dy? Mm-hmm. Correct. So someone asked, you determine it by the way it is stacked, correct? This is correct. You determine it by the way the disks are stacked. If you notice, right now the disks are being stacked on the y-axis, so therefore we are using our AY dy. So let's go ahead and write this down. So this is the one that we're going to be working with, AY dy. And before I go ahead and introduce our equation or the function that we're going to be using, what are my limits? So from where to where? So from where to where do I have to go ahead and stack the disks? Where do I start stacking them and where do I end? Where do I start stacking them and where do I end? So if you notice on the previous one, we actually did AX dx, and the reason for that is because we stacked them horizontally. This one, we're stacking them along the y-axis, so our limits have to be in terms of y. So we are stacking them beginning at 0 and we're ending at 1, right? Because this is the graph. So let me change the color of this one. So this one, let's make it purple. So the purple line is going to be our y equal to 1. Okay, so that's where we begin, that's where we end. So it's going to be from 0 to 1. And then a of y is going to be our equation, which we already have here. So now all that is left is to go ahead and plug in everything. So it's going to be 0 to 1. And then a1 is going to be y cubed. And then, well, actually, I didn't leave enough space because remember, what is the area? So what is the area of this disk? The area or the face of the disk? It is pi r squared, right? So pi r squared on dy, and then substituting my r, which is my function, is going to be pi y cubed squared dy. So far, are there any questions on how to set up the integral? Any questions on how to set up the integral? Remember, setting up the integral is the hard part. Setting up the integral is the hard part. Okay, so I don't see any questions on the chat, so we'll go ahead and continue. So let's go ahead and take the, first, let's simplify it, and then let's take the antiderivative. So this is going to be from 0 to 1, pi y to the 6 dy. And this is going to go ahead and have 0 to 1. Oh, actually, we can take the antiderivative already. So let's go ahead and do that. This is going to be y to the 7 over 7 from 0 to 1. Always remember to divide by the exponent that you have here on top. So we add 1 and then we divide by that exponent. So go ahead and finish it for me and tell me the answer on the chat. And thank you, Ladra. Someone in the chat asked, can we keep the pi inside? Yes, you can definitely do that. However, I find it easier for me to have it on the outside so that I don't have to continuously keep on writing it. I like having it on the inside. That's just a particular preference. However, you may have it on the, I like having it on the outside. You can have it on the inside if you wish. Okay, so I already have some answers. Thank you for the question. So you do have to leave it in terms of pi. I believe on the answer sheet that I provided for you, it only has the answer in terms of pi. So I think it's better if you leave it in terms of pi. So let's go ahead and look over here. This is going to be pi. And my first one is going to be 1 to the 7 over 7, and then minus 0 over 7, and then close parentheses. So my answer is therefore 1 over 7 pi. Any questions on this one or the difference between using dy and using dx? So don't use decimals in answer. For today, it's better if you use the answer in terms of pi, please. Just double check. We have to draw the graph to show our work. Yes. So again, when you go ahead and do these problems, please go ahead and provide both of the graphs for me, please. We will be using these graphs later on when we get to more complicated things like washers and such. Okay, so let's go ahead and start on our last problem. And then actually, so guys, it looks like we've run out of time. So let's go ahead and take a 5-minute break, and then I'll go ahead and send you guys into break rooms. I'll go over the last problem after you guys work in your breakout rooms for a bit. Okay, so go ahead and take a 5-minute break while I make your breakout rooms, and then we'll do this last problem before you guys leave. And of course, so I can put it back. You still need it. So let's go ahead and